Hi everyone. So let's get to the problem directly. Where's the problem? Here it is. Wait. Yeah. So now here we have a square distribution of charges Q, 2Q, 3Q and 4Q. They are all placed at the vertices of a square and we have to calculate the net force on 2Q. Now I have a general formula to calculate force between any two charges. Now, suppose the position of charge 1 is at R1 and position of charge 2 is R2. There could be any test charges. Now, the force F21 refers to the charge on force on F2 or on charge 2 due to charge 1. So, K is the constant, Q1, Q2 are their given charges, and this cap R21 is the direction bit from R1 to R2, and this R21 is the position is the magnitude between the distance between these two. So we are going to use this formula to calculate the force on 2Q due to rest of this Q, 4Q and 3Q. So let's calculate the first calculate. Wait, I have to select the pen. Yeah, fine. Let's do it. So now FQ will be given by KQ 2Q. The magnitude of distance between them is L, so it will be L square, and then we will multiply it by their directional vector. Now, let's calculate it. Now, we assume that this point 4Q is the origin, so the position of Q is, say, so position of 2Q is uh, R will be equals to L I vector plus L j vector. This is the position of second charge 2Q, and the position of first charge will be 0I minus Lj. So the position will be Li. This is the vector, and its directional derivative is I cap. So we'll put here I cap. Here we got for the uh, due to set first charge. Now let's calculate for F3Q. It will be also K3Q 2Q, and distance between them is also L square. Now for the position vector. Now the position vector will be 2 and okay, let's see. Let's talk about it. Okay, so the position vector of 3Q is L0, and here it is L and L. Let me make it clear. It's looking like a 0. Sorry. Okay, fine. So the position vector will be now position vector of 2Q. We know that it is L. Position vector of the x component of position vector of third point is also L I cap plus the position vector of the y component for the second charge is L, whereas for the y component of the third part is 0 j cap. So the vector is Lj cap, and the position vector, that direction vector is j cap. So here we will put j cap. That's it. Now let's go for 4Q. K 4Q. Sorry, just yeah, 2Q divided by. Now here the position. Just let's first calculate the position vector. Okay, so the x component for second point, second 2Q is L, and whereas for 4Q it is 0. Similarly for jth component, it will be L minus 0 because we assume that the fourth charge is at the origin. So we get L I plus J. Now its direction would be equal to I plus J by under root 2. We have just took the magnitude. This is okay. What we have done, that we have just divided by its whole norm. So we got this, and so the magnitude would be equal to n square plus l square equals to under root 2l. Sorry, yeah, under root 2l. Now let's go. So here we will use the magnitude 2l square, and this position vector we will use r cap. Okay. Okay. So from the theory of superposition, we know that uh, f net equals to fq plus f3q plus f4q. Now let's sum over it. Let me zoom it out. Now, wait, fine. Here we have all the expression. I'm going to put all of them together. So I'm going to take q and k common. Also, L square will take common. So it would look a much simpler form. Wait, k q square. Sorry, some mistakes. I'm very sorry for my handwriting. And this will be first expression will be 2I. Second expression will be 6j, and this uh, third expression will be 8 by 2 into 2 root 2, I would say, I cap plus j cap. So the whole expression would look like, yeah, we will combine all those x and y component. So it will look like I cap 2 plus 8 by 2 root 2 plus j 6 plus 8 by 2 root 2. Okay, this is the net force. Now our aim is to calculate. Wait, let me look at the question again. We have to find the magnitude and the direction of the force. So the magnitude, first we have to calculate the magnitude. So wait, why it's not working? Yeah, so magnitude. We're going to calculate the sum of it, okay, of both of them. Now this is already common, so we will get this expression f q square by l square square root of this whole square and this whole square. So it will look like okay, 4 plus 64 divided by 4 into 2 divided by 8 plus 2 into 2 cos 8 by 2 root 2 plus 36 plus 64 divided by same 8 and 2 into 6 into 8 divided by 2 root 2. Okay, kq square by l square. Here we got 4, 8, 12. Okay, 12 12 plus 36, 48, 48 plus 8, it would be 56. Okay, so we got 56 plus, now I got this expression, so it would be 422 by 216 by root 2 plus 48 by root 2. So if we sum it over, we get, let me make it simpler and let me directly give you the magnitude. It's like a pause it for a minute. Yeah, so now let's do it. Now this will be equal to whole square will be equal to eight. So, okay, q square point l square square root of 101.26. So the total magnitude would be equal to 10.006 k q square upon l square. Now, if you want to calculate the direction, so there's a very straightforward formula for direction. Let me show you. For direction, let's go there, just beside there, okay? So it would be the tan theta would be equal to the y component divided by the x component. So it would be like 6 plus 8 by 2 root 2 by 2 plus 8 divided by 2 root 2. Okay, now let's divide it. So let me use my calculator. It will be equal to 8.2, sorry, 8.828 divided by 4.828. Sorry. So the theta will be equal to the tan inverse of both of them division. It will be 8.8. 1, 1. Okay, so its tan inverse would be equal to, let's see. Yeah, so the net direction would be theta would be equal to around 61 degree, and this 61 degree would be equal to the, for example, this is the position of our charge 2. So this theta would be, suppose this is the x-axis, so this would be the theta degree above anti-clock counterclockwise to x-axis. So we got the theta and we got the magnitude as well. So I really apologize for my bad handwriting. So I hope it would help.